Hello, Professor Ignacio, fellow classmates. We're Group 8, If You Can Build It Construction, presenting our Fall 2020 term project for CE498. We selected the electrical and computer engineering building for our project to do our construction plan on. We are all grad students, and you'll get our introductions just to put a face with a name as we go through. All of us are presenters. Just an overview of the phases. Everyone's familiar with this from our lectures, as well as your work on your projects, and each of our presenters will go into more detail on each of these sections. Introduction, again, this is our final project for the ECEB at the University of Illinois at Urbana-Champaign, and it will cover the various phases of the construction plan in detail for our proposed build of this project. And then the project team, here are the key players as listed below. A little bit about this, just as you review the bullet points, the main thing is there hasn't been a significant structure besides at one time a gravel parking lot in where our building is proposed to be sited. So there's not a lot of concern underground constraints and stuff. There's some existing utilities that are identified on the map for demo. But as always, we'll coordinate with Julie and the underground dig to have all utilities passing through the site identified prior to digging. So just general orientation, this is in central Illinois. So in the region, in the city of Champaign, right where the 57 hits the 74, more in detail within the town of Champaign. It is on the northern end of campus of the University of Illinois. And then the purpose is obviously to provide the university, and more specifically the electrical and computer engineering department, a modern mixed-use educational space just to maintain relevant, competitive in bringing in both faculty and students into the program. And then here's some of the objectives. I'll let you read through these on your own, but of course, you never just want to give your owners just exactly what they, just baseline. You always want to exceed the expectation. So hopefully we become the contractor of choice for them. And then this is a LEED Platinum certification, which means that it is a sustainable project and something that the U of I is committed to. And then, of course, taking safety into mind and then partnering with the various stakeholders is always important. Switching over to our mobilization phase, here's the general highlights of this phase. Number one, being the top one here, is to, of course, minimize the impact on the university. If we're making a tremendous amount of noise or just disrupting traffic and whatnot, while they are getting a new building in a couple of years, it's not very conducive to what they're trying to do, educate students and do the research and whatnot that the faculty does on the day-to-day. And then each of these sub-bullets just support that. Here are the various phases that we'll talk through going through, but this just gives an overview to see how they interact with each other and transition. The ones that are a little bit off is this site work and excavation, and that's just to complete some of the streetscape work and then the site improvement work, which has to be done at the end, because if you did it early, then you come back and you're driving over it or whatnot and potentially damage it. The MEPF, they're just involved early on the underground demo work to make sure it's capped off safely and properly. So with our site layout, we have Wright Street on the western side of our project. We have good circulation along the vehicle access route, and that also not only allows us to take in deliveries through our vehicle access gates, but also to have an area around the building that is planned to remain accessible to construction equipment loading materials into the building, cranes, concrete trucks, whatnot. So it just gives them a free flow of movement around the building instead of accidentally putting, material lay down there, and now you have to reach over it or whatnot to do work on the building itself. We're putting our construction trailers off to the side, so they're still in close proximity to manage the work on the project, but they're out of the way where they're not going to get in the way of direct work. And then here's the fencing that we'll use along Wright Street. It has the Jersey barriers because Wright Street has vehicle traffic. So you mitigate that with a structure that can protect that. On the north, south, and east sides of the project, it'll just be this portable panelized fencing. On the drive in and out of the project site, we have these mats that help collect the dirt from the tires of the vehicles going on off site, just to keep the roads a bit cleaner. Temporary power poles, since permanent utilities will not be in place yet. And then job site trailer, and then portable toilets. So this slide just shows us the recommended routes that we'll provide to our workers and our contractors for bringing in heavier deliveries, equipment, long trailers, stuff like that. And what this circulation really does, it just allows large trucks to moving the quickest, largest routes into traffic and avoid going through campus and places of higher congestion or more foot traffic. So we anticipate that road closures should be a minimum, but potentially a large delivery or some of the road work happening along Wright Street may require it for short periods of time, which we'll coordinate well in advance. But this is what it would look like. We would have signage at both ends of Wright Street, at White and Clark Street, and then within a 1 block radius of the closure, there's streets available to reroute that traffic. So it's not moving people more than a minute out of their normal flow. And there are a few bus routes, but again, they only have to move 1 block over. So even if someone needed to, or there was a stop off of Wright Street, they could easily just catch it at an alternate stop. And I'll be transitioning with Ryan, who is going to cover our site work and excavation phase.
All right, thanks, Aaron. So my name is Ryan. I'll be taking you through the site work and excavation. To start with, we need to clear the site and then utility relocation, followed by the bulk of the work and excavation, and then the utilities backfill. And finally, like Aaron said, at the end of the project, we'll do some landscaping. So yeah, to start with, we do site clearance and utility relocation. So some of the items that we need to keep include bike racks, brick pavers, sidewalks, curb and gutter, and some trees along the perimeter. An electric utility line underneath Wright Street needs to be removed on the west side, and then 2 sewer lines on the east side need to be relocated about 15 to 20 feet from the current positions eastward, so that their lines do not intersect the future corner of VCEB on the northeast side. Some of the equipment used to do this work includes a backhoe loader, hydraulic excavator, and a boom lift. I should note that on the south side, there's a water line and a gas line that needs to be protected, and a water line on the east side that also needs to be protected. So just a top view of the excavation site. The red line represents the at-grade elevation, and the blue line represents the foundation. The approximate length is 210 feet, width is 240 feet. You kind of see that the slope sides are on the west and north, and the east and south sides are sheet pile. The sheet pile sides are done so because to protect the water and gas mains, as mentioned. And then there's also a ramp that connects the Wright Street to the construction site at the foundation level. Should note that the total volume is approximately 34,000 bank cubic yards. Factoring in swell, this equates to approximately 42,000 loose cubic yards that need to be hauled from the site. Moving on to excavation phasing. So before any of the bulk excavation begins, you need to make sure that the sewer is relocated, like I said, 15 to 20 feet to the east. Start phase one, you start in the northeast corner and work your way west and south. Once you're about 50%, once about 50% of the volume has been hauled, you can start the formwork. And then once the phase one north site has been totally excavated, you can move on to phase two. Again, start in the northeast corner, work your way west and south. Once 50% of that has been completed, you can start the formwork. So the equipment used to do the bulk of the work will be a one large bucket excavator, two small bucket excavators, one front end loader, one backhoe, and one grader. And to actually haul the material away, you need 6 dump trucks, which keeps the excavators approximately 100% utilization. One large was chosen instead of 2 because having more than one would probably cause some site congestion and would probably reduce the efficiency of all the excavators. The 2 small bucket, one front end and one backhoe, will be used to assist in the bulk of the excavation, as well as to perform some of the smaller, more detail-oriented tasks. In total, we estimate that it'll take 6 weeks for the excavation. At the end of that, everything will be demobilized except for one small excavator, the front end loader, and the backhoe, which will be used for the backhill and utilities and the landscaping. So this is a diagram of the new utilities that we placed around ECEB. It shows some of the connections and the foundation walls. So the rough ends take place after the foundation walls are in place. You can see there's a storm line that wraps around the entirety of ECEB. There's also several electrical lines, as well as several tie-ins to the water main on the east side. And finally, we get to the backfill. Backfill takes place after the utilities are installed. And we do this work with a small excavator in the front end. And then finally, once the exterior cladding and roofing are finished, as well, and making sure all the major equipment is demobilized, the landscaping can begin. And that takes us to foundations.
All right, thanks, Ryan. My name is Roland, and I'll be running through the ECB foundation systems. So the foundations for this project will consist of both spread footings and a 1 1/3 foot thick foundation wall along the base perimeter. Footings along their perimeter will also have square piers. We will use traditional timber formwork for the footings, and because the walls and piers are something like 21 feet tall, we will use metal formwork for those. And this next slide shows a typical column pocket. And what we're saying here is that we will build these foundations starting from the footings, followed by the piers and wall monolithically. And from the basement floor plan, we've identified where each footings are. And there are also footings on the first floor, supporting the cleaning room and the south hallway. And here we've identified the location of the tie-ins as coordinated with our MEP teams. And from our preliminary QTOs, we've estimated that the foundation system requires little over 3,100 cubic yards of concrete, which translates to 392 mixer trucks. That's assuming 8 cubic yard capacity. And this next slide just shows how we came up with these values based on the foundation floor plan and the foundation schedules. As for major equipment, we will need a mobile telescoping crane specifically for the foundation wall construction. We will need multiple mixer trucks on site per day. A high-reaching telescoping man lift would also be required with an 85-foot reach. These cranes and man lifts will also be used for multiple trades. So this 85-foot reach would be needed to work at the roof level. For footings, we will use a mobile trailer-mounted line pump And for the walls, we would use a single pump truck. And because we will be pouring the walls from the top of the slopes, a Putzmeister M315 should provide the necessary reach. It has a 26.3 meter horizontal reach and a 31 meter vertical reach, which would make it a viable option for both foundation work and superstructure work. It also has a 5-arm boom, which makes it a little bit more flexible. And onto the phasing plan. The first part of the phasing plan covers the footing construction that is to take place simultaneously with excavation work. Looking back at our excavation phasing, we will begin the north side footing work concurrently with the south side excavation. Work should begin at the vehicle ramp and follows the perimeter in a west to east fashion. The pouring for north side footings will be performed using mobile line pump and mixer trucks that are staged in this orange staging area here, while the formworks are being installed on the south footings. Foundation work in the staging area itself will only begin after the walls are poured, which brings us to the second part of our phasing plan. This bit should be coordinated with the superstructure team as closely as possible, such that the erection of the north building can go concurrently with the pouring of the south side wall. Similarly to before, the north side wall and pier formwork are erected concurrently with the south footing pour. And once all footings has been poured, we will construct the northern wall first, again in a west to east fashion. We will then double back to pour the interior piers, meeting at the east end. And from here, we will pour the rest of the south wall. And lastly, the excavation, formwork, and pouring of the central footings are carried out in that order. This is an illustration of that process, but also importantly, this illustrates where our trucks will be during the various stages of this phasing. In general, the pump trucks will make its way around the vehicle access way, with mixer trucks staged in the material laydown areas. This yellow box here illustrates the staging for mixer trucks and line pumps for phase 4. And on that topic of mixer trucks, delivery schedules were made based on ASTM C94, regulation stating that the ready mixed concrete should be poured within 1.5 hours of mixing. So for the exterior and combined footings, we scheduled 72 cubic yard pour per day. That should be done on the same day as when the formwork and rebar is placed. That translates to 9 trucks a day, but for space efficiency, we will limit delivery to 3 truck deliveries at 1.5 hour intervals starting at 11:30 a.m. With 72 cubic yards a day, we would expect the footing pour to take about approximately as long as the completion of site excavation. And that's also accounting for a 1-week cure time. For phases 1 through 4, we intend on having formwork and rebar installed a day in advance to allow for a full day's pour, given the same 3 truck per trip policy, which sums up to 120 cubic yard pour a day or 15 trucks. And as for the basement slab itself, we will coordinate this with the superstructure team. We plan on pouring the basement slab concurrently with the first floor slab using the same pump truck as before. The mixer truck and the pump trucks are to be placed at the east or west side of the site. It should not be on the vehicle access at any point because that will be primarily be used for superstructure staging. The phasing plan will start again from the north side, working down to the south side and ending at the central side. Because we will be pouring from the sides, we will need to pour in halves. So formwork would be required to split the site in half. We would pour from the western end first, moving towards the center, then likewise from the eastern end. The central site will be poured from the east to west, working its way towards the ramp. So columns for a specific region should be in place before the respective slab is poured. This is just something that we will need to coordinate with the superstructure team. Isolation pads for mechanical equipment should also be poured with this slab. And we will use timber formwork for both the isolation pads and the slabs. And again, this is an illustration of that process. Here we see where we're placing our pumps and trucks on the west end and similarly on the east end. The central site, we can see where we're staging the rebar. And finally, all unused foundation equipment should be transported to the first floor and kept at the northeast laydown area. The line pump, because it's not required to pour the basement slab, can be returned after phase 4. By now, we should have gradually stripped all the formwork after a 1-week cure time. Formwork should be removed offsite as soon as possible and stored in the south laydown area that is closest to the vehicle access gate. And again, the mobile crane and the man lifts are to be transported to the northeast laydown area, kept there for superstructure use. Pump trucks will also be returned to the supplier until superstructure requires it. And with that, I'll hand this off to David to run through the superstructure staging, phasing.
All right, thanks, Roland. I'm David, and I'm in charge of the superstructure and electrical. Just for the superstructure analysis, we have a gravity low resisting system consisting of composite decking, top of steel beams, and they're connected to each other using shear connections. And the deck is connected to the beams and girders using studs. For lateral load resisting system, we'll be using a steel frame, and they will be connected. The beams and girders will be connected to the columns using moment connections. For the phasing, we will begin on the north section, denoted as section 1. We'll proceed to the south section, denoted as section 2, and then we will finish with the central section. The equipment required for the superstructure, we will bring in a crawler crane for the column placement. This is just so we have adequate placing of the columns. You know, they require movement under load. So, and they're also heavier than the beams and girders. The heaviest steel column being 4.5 tons for W14 by 145 spanning 66 feet. We will use the same mobile telescopic crane used for the foundations for the beam and girders. The heaviest one being 3 tons. We will use the same mixtures of over trucks used for foundations, and this will be done for the pouring of the concrete deck on top of the metal deck, or the concrete on top of the metal deck. The quantities for these are the 375 cubic yards per floor for section 1. This amounts to 48 mixes per floor. And for sections 2 and 3, we will, the total cubic yards are 215 cubic yards per floor, amounting to 28 mixes per floor. We will use man lifts, the X85XC telescopic and boom man lift will be used, and multiple may be necessary due to the fact that multiple workers may be working on the same beam or multiple workers may be working on different beams. Just to reiterate the material laydown with vehicle access lanes. Yeah, so here is the ECEB shown here. So we will reorient the mobile crane to this location used in foundations. We will bring in the crawler crane. These red X's denote the vehicle access points. So we will reorient the mobile crane to this position. Obviously, this isn't to scale, so this can move along this vehicle access lane. We will bring in the crawler crane oriented to the position shown. And then we will deliver the 1A columns. So we're going to split this into 2 for the first floor, just so that the columns have adequate bracing, just so they're not left alone after we place them. Yeah, so then we'll deliver the 1A columns. These are the ones, the 1A columns. The blue ones are the ones bolted to the footing, and these are the ones bolted to the foundation wall piers. And we'll install them on a west to east basis. So yeah, we'll deliver the 1A columns here, and then we'll deliver the 1A beams and girders here to the beam and girder staging area. These are the beams and girders for the 1A section. then we will stage and place the 1A columns here. We will place them using the crawler crane. And then we will, after these are placed, we will place the beams and girders using the mobile crane while the 1B columns are being delivered and placed. Note that while this is installing the 1A beams, this crawler crane will be occupied staging the columns so they won't overlap. So this will be working on this area and this crawler will be working on this area. So there'll be no overlap. So once these columns are staged, we will place the columns on the 1B after they're staged. And then we will do that while delivering the beams and girders for 1B. Again, there'll be no overlap since this will be working in this area while this mobile crane will be staging the beams and girders. And then after that, after all the columns are placed, we will place the beams and girders for 1B. After all the framing is done for the first floor, we will remove the crawler crane from site, and then we will stage and place the metal deck using the mobile crane. So we will stage it here. Obviously, there'll be no beams and girders staged here at this point. So we will just stage the metal deck here. At this time, again, the foundation personnel will be pouring the basement, slab on grade. After this is done, we will bring in this pumper truck to this location. We're bringing mixers here to pour the slab, and then we will pour the first floor slab while delivering the second floor beams and girders. This area will be cleared because the metal deck will already be in place. And then after the first floor deck is poured, we will remove these from site. It's optional, but we prefer to do so. So yeah, we will remove this from site and then erect the beams and the girders for the second floor. And then we'll repeat that for the top floors, and then this crawler crane will be brought in for the top columns. And then after this whole section superstructure is done, we will repeat with sections 2 and 3. And these are just for section 2 and 3, these are the orientations. They'll follow the same beam girder column scheduling and delivery schedules. So you can see we will move the mobile crane from this location to this location, and then from this location to this location for section 3. For demobilization, as coordinated with roofing, so after each section, 1, 2, or 3 superstructure is complete, the mobile crane will stay in place for the roofing for that section. So for section 1, this mobile crane will stay for the roofing. The roofing will also use concrete mixers and concrete pump truck because the roofing is basically the same as the typical floor slab, except it has some coating on top. They'd be staged in the same positions as superstructure. So they'd be staged in these areas right here for the concrete. They will leave site once the roofing is complete, and then we will begin with section 2. So when roofing is done for section 1, the concrete equipment will leave, and then we'll bring in the crawler crane to begin section 2. And this mobile crane will reorient to here to begin section 2 superstructure. And after the middle section, which is the last section, after that roofing is complete, the roofing personnel is responsible for demobilizing whatever equipment is left on site. And with that, we will switch it over to Breville for exterior cladding and roofing.
All right, thanks, David. Hi, my name is Breville Holder, and today I'll be going over the exterior cladding and roofing plans for the ECB. So as you can see in this image here, here's our material staging locations for the exterior cladding and roofing. So in the north section, similar to that of the superstructure, we'll be staging the steel decking of the roofing. On the east section, because it's our largest section, we'll have our masonry and rain screen staging. And because our largest curtain wall is located towards the south end of the section, we'll have our exterior glass staging location there. So as David just said, the roofing of the ECB can be considered an extension of any of the composite floors. This design was selected due to the fact that the roof of the ECB is meant to hold our mechanical equipment and the solar panels for our LEED Platinum certification. So all the equipment selected were base of that used in the superstructure. So to reiterate what was just said, for our north and south sections of the building, we'll be using mobile telescoping cranes. In addition to this, for the roof, we'll also need concrete mixers and concrete pump trucks. So analysis similar to that of any of the floor plans, we'll be using a steel deck that is welded into the frame of the building. From there, we'll pour concrete on top of the steel deck, and we'll add a layer of EPDM, which is a polyurethane protective layer on top of that as well. So our phasing for roofing will follow that similar to the superstructure. So we'll go section 1, 2, and 3, go working west to east. In the picture to the bottom right, you can see our rough locations where we'll be having our superimposed loads for our roof. So at the south section of the building, we'll house our solar panels, and towards the north section, we'll have our mechanical equipment. And in order to make sure that our flat roof is draining properly and we have a nice even pitch, we'll be using roofing boards that are pitched towards these drainage locations located across the roof. So for the exterior cladding of the building, we'll be using 3 major types of cladding. So the first will be a masonry exterior wall with terracotta panels. The terracotta panels in this case will be our rain screens. The second will be a masonry exterior wall with an exterior granite or exterior stone. This will be used at the base of the first floor, and throughout the sections of the building, we'll have curtain walls and windows. So for specialized shipments, because these glass curtain walls and windows are super expensive and designed specifically for this building, they'll be shipped in specialized crates and brought to the job site at strategic times to make sure that they're not broken throughout this process. Additionally, for the exterior cladding, we'll need man lifts, truck mounted cranes, telehandler lifts, framed and braced scaffolding, and mass climbing scaffolding in order to set up our exterior walls and add our rain screens. So breakdown of these equipments and why we need it. So our truck mounted cranes will be used to lift our window panels and move our material around our job site. Our telehandler lifts, as seen in the bottom right, will be used to move our cement bricks onto each floor so that our masonry personnel can start laying the exterior walls after the superstructure is built. Our scaffolding will be located across the entire outer facade of the building once the exterior wall is made. So these scaffoldings will be used for placing our rain screens and creating the brackets needed for that. And in addition to all this, because our scaffolding may not be enough, our man lifts will be there to assist with the exterior walls and the rain screens. So we look at how these rain screens are installed for our exterior cladding. Once we have our concrete block exterior walls made, we add a protective layer of air and vapor barrier and insulation to the outside facade of the wall. From there, we install a support rail that the terracotta panels or the exterior granite or stone are attached to, and these support rails are directly drilled into our exterior wall. So if you look at the material needed for each face of the building, for our north face of the building, we'll roughly need 27,000 cement bricks. We'll need roughly 24,000 square feet of rain screens and roughly 4,000 square feet of glass. So because our north section, our north face of the building is the only one that doesn't have a curtain wall, this will require less amount of glass compared to any other face of the building. As you can see for the south face, we have this massive curtain wall located right there. And for this and the fact that the east section's curtain wall is located close to the south end, we decided to stage our material here. Sorry, one sec. Similar to that, our east and west faces, you can see that we'll need roughly 10,000 for our east face and 50,000 bricks for the entire exterior wall. So demobilization for exterior cladding and roofing. Since this is the final phase of the exterior aspect of the building, once we're completely done with our exterior cladding installation, all equipment will essentially, all major equipment used for the foundation, superstructure, and exterior cladding and roofing will leave the job site. As David alluded to earlier, for our roofing section, we'll follow the same demobilization plan as discussed in our superstructure section. For the exterior cladding, we'll have to take down all the scaffolding located around the building. This will leave certain pockets of anchor points where we did not add our rain screen. So our man lifts will then fill in these gaps with the appropriate rain screens. Our mobile cranes and lifts could be returned to our supplier. And because all future sections will have our material storage on the inside, we could begin clean up our site and begin the landscaping phase. So next, I will hand it over to our mechanical section.
All right, thank you, Breville. Again, I'm Aaron, and I'll be kicking off our MEPF section, but we'll be going into detail on the mechanical, followed by the rest of our team members on the other sections. So this is just a site layout that covers all the MEPF trades. On the north and south side, we've allocated space so that it's not just one designated side for one trade. This is because all the MEPF trades will have a lot of miscellaneous piping, ductwork, wire cabling, whatnot, that it's best to give them access from both sides of the building, because those are where our two major structures are on the north and south side. If you centralize it, that means you have a lot more trips, potentially out to farther points. So our phasing overview, and just before that, so the MEPF trades just in general for the purpose of this will be staggered by about a week. So mechanical will lead off, followed by plumbing and fire protection, followed by electrical. And that's because typically, as discussed in the lecture, the larger equipment, such as ductwork, that's more rigid and unwieldy to work with, needs to go in first, because piping and wiring for the other trades can kind of work around it. For mechanically specifically, here's an overview of our phases. So it's pretty much 1, 2, 3, 4, 5, and we just designated them with the M, just so you know we're still in the mechanical section. So we'll focus on 1 and 2 because 3 through 5 have later slides that will go into more detail. But 1 is just to make sure that mechanical is involved in the cutting and capping of any of the existing utilities part of the demo phase, to make sure it's done properly, rather than just a demo sub going in there and, you know, they could remove it, but if it's live or whatnot, you really do need that technical expertise of the trade to be there. And then foundation, whether the MEPF trades do it themselves or whether they're just technical advisors, they will work with the foundation workers to ensure that any penetrations that need to pass through are either blocked out, identified to be cored later, but ideally they are blocked out so that coring does not have to be done at a later time. And then M3 is rough-in, M4 finishes, and M5 demobilization. We'll let you read that, but we will discuss those further as they have further slides. So here's our equipment for the mechanical section. We have our telescoping crane, which helps us lift the rooftop air handling units because of the reach. The variable reach forklift will not reach those levels. So we need this mainly for that. And then some of the upper floor equipment, it can also play assistance. And this will be on site from previous phases. The variable reach forklift will be bringing on site. And this will do a lot of the legwork for moving the air handling units in the basement on the south building, the heavy heat exchangers on the north side building. The boom lift exterior just is the man basket that allows 1 or 2 tradesmen to work on the exterior penetrations, exhaust vents, intake vents, in coordination with the exterior subcontractor. And then the scissor lifts and interior duct lifter are used on the inside. So in the basements, we have the most vertical distance, 20 feet from top of slab to underside of the floor above. And so while that floor is more conducive to the scissor lift, but we will be using this one, the duct lifter, on all floors, just because it's more portable, we can take it down. And then we'll be using the scissor lifts up to floor 4, just because floor 4 is the top floor we can reach with a variable reach forklift to take these down. They allow work to be done more safely and more quickly, so you get bigger or quicker production rates. But floors 5 and 6 will have to be ladder work, just because the logistics of taking it down ladders, we have more flexibility just to take it down a stairwell or whatnot, or down an elevator. Here's some of the equipment, or the equipment that we will see in phase 3. So if we just read through this, it's the phase known as rough-in. So this is where the bulk of the work goes in. So all your ductwork or your pathways to your fixtures from the point of origination. Sorry for that. I thought I had skipped a slide. So chilled beams, and we have active chilled beams in our building, which means there's forced air from the air handlings through ductwork to these. So, and then they have hot and cold water loops. You see right here that air passes over and then pushes into the room. So providing local heating and cooling in the room. Terminal air boxes have similar capacity, but you'll have multiple chilled beams in a particular room, one terminal air box leading into the room. So a combination of both these will get doing their outputs to the desired hot cold that is controlled by the thermostat in the room. The radiators just have warm water circulating through them, so those will only work on the heating side. And then the ductwork it is just the forced air from the air handlers, and it will provide hot air from the point of radiation, the air handlers either on the rooftop or the basements, but these pieces of equipment help to bring it to its final temperature. So maybe by the time that air gets to these, let's say it's 10 degrees below desired temperature, these bring them up to the final. So starting in the basement of phase M3 is our south side building air handling units, and there's 6 of them. Just to give you an idea of how large these are, they're roughly equivalent to 20 and 40 foot shipping containers that all of us see being hauled down the road or put on cargo freight ships. So this is on the south side building. On the north side, we know that these will be on the rooftop. But on the north side, which is in where all the main lines for the hot and cold water loops, as well as the steam line, come into the north building basement. So we have these 2 large pieces of equipment. They're very large and significantly heavy. So we have those, but the heat exchanger, basically, so the hot and cold water loops from the central plant of the university will come into one end of this, and then there's the building loop on the other side. And basically what this apparatus does, it allows that heat to be transferred. So the university loops are not necessarily feeding all the way into the building. They're feeding into this piece of equipment, and then it transfers the heat into the internal loops of the building. The heat recovery unit recovers some of the hot air before it's pushed out of the building. So in the winter time, instead of just doing 100% exchange of air, where you're bringing in cold air from outside, heating up to your desired temperature to save energy. As some of the exhaust warm air is leaving, the heat is pulled from it and mixed into the cold incoming air. And so the whole gist of that is that less energy is required internally in the building to get to your desired temperatures. So moving out of the basement is a little bit unique because it has that specialized backbone equipment that is only one-time places in the building because it feeds the rest of the building. On floors 1 through 6, it's really the build out starts with the vertical shafts and risers of the ductwork and piping. And then as that gets to the floor, let's just say in this case, floor 1, then after you have the shafts in, then you would build out to your main branch lines, which in this case are running over a hallway. And that's typically to make accessible to maintenance workers in the future. And then from there, you have branch line or tributary lines that drop down into the individual classrooms, labs, whatnot. So that's, you're feeding from 2 into the branch lines. And this is the progression of how we're installing as well. And then finally, you terminate at the fixtures. So these would be your chilled beams and then radiators or whatnot. The final point where the air is going to be flowing over some cooling element or some heating element, and then interacting with the users of that room. So M4 is testing and then programming. And we have some visual examples. I'll let you read through the text, but as I talk through the visuals, it will hit on the text as well. So this one is just kind of a sarcastic one, but to annotate air pressure. Air pressure is important for door closures and emergency systems because it potentially, if you're overpressurized in some rooms and doors aren't closing properly and whatnot, and it can be not only an annoyance of like trying to open a door, but also fire safety issues. This is just to discuss, you know, especially today with the modern systems, a lot of them interact with each other and send each other signals. So everything has to be programmed and just make sure they're talking correctly. Same with this visual here. That's just a interface that shows the different components of the system and then the diagnostics on them. It's small, but some of them say on, off, and then the different temperature set points. Thermostat, we all know that. And then this is just an example of, you know, testing to make sure all the ductwork is sealing properly, and then troubleshooting if there's any issues, you know, whether from the program controls or just a visual, he sees something that's damaged. So we won't go ad nauseum into this, but here's the long lead time materials. And typically in most buildings, all these are the large piece of equipment that we were talking about putting in the basements. On the north side building, it'll be the rooftop air handling units. But while they may be similar to other buildings, these manufacturers don't have a large backlog just sitting around because they take up a large amount of space. And then these pieces of equipment are specialized for the building. Some of the components may be fairly common, but other aspects will be specialized where they're made to order. So they're not just off the shelf. And then these are more off the shelf items. And the long lead time materials, you know, these need to be well coordinated with the designer and procured well in advance, months in advance, to make sure they're on site when needed. And then jump into demobilization. So all the equipment will stay on site: the telescoping crane, boom and scissor lifts, variable reach forklift, because it can be used for follow-on trades. And then the duct lifter and the mechanical specific equipment will be removed from the site. And I will be followed by David for the electrical section.
All right, thanks, Aaron. So I'm David, and I'm back to do the electrical section. The electrical system analysis, there are three main systems. There's a main electrical system, which consists of the tie-ins, or duct banks, connected to a unit substation in the basement. And this is connected to the switchboards and transformers in the basement. And then these are connected to the distribution panels and the busways, which are located at each electrical room in each floor. And then these are connected to the individual room panels. The other system is the emergency electrical system, which consists of an emergency generator located on the first floor. And this is connected using a duct bank to switchboard and transformers on the basement. And these connect to automatic transfer switch, which controls the use of the emergency electrical. So if it's needed, it turns on. If it's not needed, it's off. And this connects to the unit substation for use of the main electrical system. The renewable energy system, just to achieve LEED Platinum certification, consists of solar panels located on the roof. And then these connect to the inverter, which then connects to the unit substation at the basement. As you can see, the emergency and renewable systems tie back to the main electrical system in some capacity. This is just a small schematic on how the main electrical system works in a building. So the large components in the basement, you can see here, this is the large unit substation here. These red lines indicate the tie-ins, as were alluded to by Ryan in the site work. This tie-in is from the campus chiller plant on the east side. This connects to the unit substation for the main electrical system, and then this connects to switchboards and transformers. You can see here, this is the unit substation. These are some switchboards and transformers. The unit substation is just to reduce the voltages of the service line down to usable levels for the building. And the switchboards are just to redirect the electricity and to turn it off if necessary. And then transformers allow for further voltage decreases for use in individual floors. This tie-in here comes from the emergency generator located around here. I'll show it in the next slide. So this duct bank leads onto here, and this connects to a switchboard, which then connects to the automatic transfer switches, as shown here. So this connects to these, which then control the use of the generator, and then these connect back to the unit substation. This bottom tie-in is just for some technology. I didn't specify in drawings, but yeah, this is a technology room, and this ties in, this south tie-in ties to that. So for a typical floor, there are two electrical rooms. This is the one in the north side. There's another one on the south side, but it's basically the same orientations. So this is the distribution panel. This comes from the unit substation up to the floors, and then this connects to a busway, and then this connects to the panel, which then leads off to, you can see this line, it leads off to the, individual room panels. And this is the first floor south section. So you can see the emergency generator is located out here. So this would be around here in this map. So this connects to this for the emergency electrical system. And then to achieve LEED Platinum certification, the renewable energy system, these are solar panel locations on the roof. Consists of photovoltaic cells, which convert sunlight to DC current, and then the inverter converts to AC current. And this is to the unit substation and switchboards. There would be a 3% reduction in power during this process. There are a total of 25 solar panels on the roof, and will account for 11% of the building energy by the year 2020. The equipment required with the installation of the electrical system be a forklift, same as mechanical, just to bring in the large basement components, the substations, the switchboards, the transformers. Mobile crane will be used for the solar panels, just because they're fragile. You want to use they don't want to be too rough on them. And then the scissor lift and ladder, just for the placement of the luminaires up top, and the ceiling rough-ins. You see, this is a mobile crane installed on the solar panel. This is the forklift, and this is the ladder used. For the phasing, for the large electrical components, we will coordinate with the superstructure and the mechanical. So the coordination with the superstructure consists of the just the large components in the basement of each section will be placed after that section superstructure is completed. So for section 1, most of the electrical large components are placed in the basement of this section. So we will wait until this the superstructure is complete to install to bring in the forklift, installing the large electrical components, and this is due for weather protection. The first floor decking will provide weather protection, and the foundation will also. And we will make sure there be no equipment overlap near the ramp. There'll be some crawler cranes here for section 2. We'll make sure these are taken away, and just for the forklifts to be brought in to bring the large components. And then the coordination with the mechanical guys, just for the usage of the variable reach forklift. Most electrical components are in the north and most mechanical components are in the south, so it shouldn't be an issue. For the duct bank, which is the tie-ins for the phasing, we'll coordinate with site work and excavation, foundation of the superstructure. The coordination of the site work, just there's an existing, this bottom duct bank is the existing one. Make sure just to clear the existing utilities, and then the duct bank paths will be excavated. For the foundation coordination, it's just that the electrical tie-ins will be considered in the pouring of the foundation wall. And coordination with the superstructure, the north tie-in will be built after the connecting unit substation has been placed. So just placing the PVC piping, this is some PVC piping, and then the ties, and then pouring the concrete. These will tie into the unit substation for the north tie-in. And then once the generator is placed, the other duct bank for the emergency electrical system will be placed. And then for section 2, which is the south section, the south tie-in will be built. So there are 3 tie-ins. The north section has 2, one for the generator, one for the main electrical, and then the south tie-in will connect the technology room. For the interior rough ends, we will coordinate with exterior cladding personnel and NEP and interior finishes. So for the exterior cladding, we just need to make sure that all interior electrical components are placed after the exterior cladding for weather protection. The NEP guys, electrical work lags the mechanical, plumbing, and fire protection by about a week. Be no overlap. And the interior finishes, we will place the junction boxes, panel boxes first. We'll make sure that there are cool holes in the flooring just for the wiring. And then the wiring will be placed last, connected into the panels and into the large components. And then the solar panels will be placed after the completion of the project. Mobilization, the forklifts. So we'll leave after the section 1 basement components, which is the north section, the forklifts will leave, and then after the second section 2 superstructure is done, it'll be brought back to the mechanical basement components, which are located in the south. Scissor lifts and ladders will be used in conjunction with the interior finishes personnel. They will be demobilized after the final interior finishing task is complete, which is usually painting. And then the mobile crane will be brought in after the entire building is built, just for the solar panel installation. There'll be no issues demobilizing. This will be the only piece of equipment on site. We will turn it over to Brian for fire protection.
All right, thanks, David. So I'll be taking you through the fire protection. So the ECEB fire protection system will connect into the Beckman Institute via a 6-inch diameter below-grade tie-in on the northeast corner of the building. Both wet and dry sprinkler type systems are used. Ceiling height is generally between 15 and 20 feet. There are 4 risers, as you can kind of see at the bottom right. There are 2 in the north section of the building and 2 in the south section of the building. And when all is said and done, over 1,800 sprinkler heads will be installed. So the phasing for the fire protection is by zone and floor. So the first phase will be with zone 1. The riser will be installed from the lower level to the penthouse. And then the cross main branches and sprinklers will be installed floor by floor, starting with the lower level and working our way up to the penthouse. Once zone 1 is complete, you move on to zone 2. Same thing, you start with the riser, lower level to the 3rd floor. And then you install the cross main branches and sprinklers floor by floor, lower level, start with the lower level, and then move up to the 3rd floor. Once zone 2 is complete, move on to zone 3, and then zone 4, and then your fire protection system is installed. So for the equipment, the mobile crane is used for lifting things like pipes, pipe hangers, sprinkler heads to the different floors. Scissor lifts and ladders are used to actually install those material. And all equipment remains on site for the remaining MEPF phase, as well as the framing and interior finishes. And with that, I will turn it over to plumbing.
Thanks, Ryan, and thanks everyone for making it this far into our presentation. We've only got 2 sections left, so let's keep rolling with plumbing. The key items here is the steam tunnel connection to the existing university steam tunnel. There are utility connections which are done prior to completing the foundation. Sewage sump pump goes around the building collecting water, and then we have our specialty equipment and water distribution. So here is our water distribution. So it'll come from the basement and it'll basically go up and split between the north and south sections of the building. The north section does go a few floors higher than you see. This will end here on the south section. So there will be a little bit more time to develop the northern section of the building. Key equipment. We'll need a mini excavator to install our steam tunnel, forklift, and skid steer to move equipment. The crane will help us bring in equipment not only to each level, but also move in heavier equipment into our basement area. We'll need scissor lifts and ladders to work at height. So for our phasing plan, we have the utility rough-in and drain tile system, which will be installed around the same time in coordination with our foundation. Standpipes have to be installed as well as roof drains before the superstructure and finishes up. Large equipment is stored and covered after our enclosure of that corresponding floor is secured, and plumbing fixtures and rough-in and specialized equipment will be our final components to be installed. So for demobilization, most equipment such as the cranes and large stuff like that will be off-rented. Scissor lifts and will be kept for framing and interior finishes, and maybe a few skid steers to move some of the larger finishes around as well. Excess material will be dumped and hauled off-site, and small presence remains for testing all of the installed equipment. Finally, we have our framing and interior finishes. There are quite a couple of interior finishes. For walls, we have gypsum board, linear wood tiles, interior terracotta panels. And for the floors, we have epoxy terrazzo, which goes throughout most of the floor, and things that are outside of the classroom, and carpet tile is mostly for inside the classroom. And there's a specialty raised floor inside of the clean room. The required equipment, telescoping forklift to lift the materials into the building wherever there's openings. Scissor lift will be used for more vertical finishes, as well as the drop ceiling install. And our specialty material is a shot blaster and grinding machine, which will help us install the epoxy terrazzo finish. Our phasing plan for this involves, it will lag shortly behind the exterior enclosure work and generally be performed in the direction of east-west on each level. Crews can work simultaneously in the phased north and south sections, which will help expedite the schedule for interior finishes. The full sequence of activities will be completed in stages. Once major mechanical ducts and electrical conduit have been put into place, it's possible to frame partitions of the associated level. After studs and partitions have been installed, ceiling grids will be roughed in and installed, and lighting and equipment that needs to be routed above the drop ceiling will be placed before the ceiling system is installed. Electrical wiring is then fed through the partitions to the roughed in outlets in the walls, and walls can be finished and painted afterwards. If the wall requires interior glazing, such as this shown here, which many walls do, they will be installed prior to painting the walls, but after most large equipment is installed to keep them protected and undamaged. The epoxy terrazzo flooring for the lobby and corridors throughout the building will need special planning for installation due to their you don't want to be running scissor lifts or large equipment across these floors, so we want to keep them protected. And so we'll try and install them as late as possible into the project. Finally, demobilization plan for framing interior finishes. We'll have the scissor lifts off rented as work lessens until all finishes are complete. The shot plaster and grinding machine are released after all the flooring is installed. The floors will be cleaned and trash removed, and the building will be turned over after final punch list is completed. And that just about does it for our presentation. Thanks so much for listening and making it all the way through, and we hope you enjoy the rest of your day. Thanks so much.